Hello everyone, my name is Adam Weiner. I am one of the co-chairs for this year's Rocket City Weatherfest. Today we're going through the collapsing can experiment. This one's quite simple. Of course, you need parental supervision for this one. We have a hot plate or a stove, a can with some water in it, an ice bath in a basin, and some tongs. The procedure is quite simple. Add about a tablespoon of water to the can. Also add some water and ice to a basin. Then place the can onto the stove or hot plate and allow the water to boil for a couple of minutes. Then use your tongs to quickly invert the can and place it into the cold water, and the can should implode in about a second or so. So here we are. If you've done the experiment correctly, you'll have a can with some boiling water, ice bath nearby, and your tongs ready to flip the can over into the ice bath. So it should look something like this. 3, 2, and 1. And there you go. So we now have a crushed can. You might be wondering, well, what happened? The science is on the board. We can approximate air using the ideal gas law, which is pressure times volume is equal to the number of moles of gas times a gas constant times temperature. For an empty can, the air pressure on the outside of the can, P sub A, is about equal to the pressure inside the can, P sub C, which is 14.7 pounds per square inch. The volume of the can, V, remains constant so long as the can is holding its shape. The number of moles inside the can is also about the same. However, upon heating the can, more water vapor is evaporated into the air. And of course, the gas constant R is a constant, so it stays constant. For the hot can, when you heat the water inside the can, the hot plate or stove, this causes the water to evaporate when it's boiling. The high temperature steam in the can, as you can see here, with an increase in temperature, in order to keep this equation balanced, one must see an increase in pressure. So we have high pressure air inside of the can, although some of that is of course escaping through the top, that's open. Atmospheric pressure is still about 14.7 pounds per square inch around the can, and the rigidity of the metal that makes up the can helps the can to maintain its shape. Upon taking the can with the high pressure water vapor inside and flipping it over into the cold ice bath, the sudden drop in temperature, in order to keep this equation balanced here, requires a drop in pressure as well, as the water vapor condenses into liquid. Since we dipped the can into water, the opening is cut off from the atmosphere, and so a vacuum is created as the vapor condenses into liquid and the pressure drops inside the can. Before the water has enough time to get inside the can to fill the void, the atmospheric pressure becomes great enough to crush the can. Thus we have a crushed can.